Hi, welcome to everyone's favourite segment, Mailbag. Yes, I'm back. Sorry for the delay, but I've been under for the last couple of weeks with the dreaded man flu. It's knocked me about. Anyway, sorry to Jason Scruggs. I was supposed to open this on the 21st, or before the 21st of August. It's obviously a Kickstarter-y, crowdfundery type thing of some description. So, sorry, I can't always open them on time. It's just an unfortunate fact of life. Got a lot going on at the moment, and anyway, let's check it out. Total eclipse of the sun. Okay, I won't break into song. No, it's a weird packaging. Total eclipse of the sun. Okay. There's a little, no, I thought there was a dot on there. What is this? Total eclipse of the sun protective sleeve. This sleeve is for stamp. What? They're stamps. Oh, track of the total eclipse across the US. Yes. That's why it's not a Kickstarter. Please find enclosed a sheet of special edition stamps from the US Postal Service printed in thermochromic ink, such that the stamp's image changes when heated or cooled, i.e. rubbed with the finger. Wow, awesome. So let's check this out. Thank you very much, guys, including Gavin Andrews, who also paid to send these things in. So these are actually from the US Postal Service. You could buy these things, and here we go. Look, a total eclipse of the sun. They're actually stamps, and it's, well, completely black at the moment, but okay, I'll just stick my fingers under the bottom here, and hopefully we'll see. Hey, there we go. I can see that change. Sorry I haven't got fixed exposure on. Now I have. But you can see that. That is very, very cool. Cool. It's not showing up as well on camera as it does in real life. It actually does work. Yeah, you can really see the difference. You can see the craters and the planes on the moon come out compared to the one next to it. That's fantastic. Thank you very much, guys. Very interesting. Unfortunately, of course, I couldn't see the eclipse because I'm here in Australia and I only went across the mainland US. Yeah, I wish I could have been there to seen it, but I have seen a partial solar eclipse before, but yeah, it's not the same, but have to see one day. The next one, I believe, that's total solar eclipse here in Australia is 2028. So, yeah, more than a decade away. Anyway, it was fun to watch everyone's video of that. Every science video blogger out there cover the thing because it was all over the US. And one day. Next up, we'll do the biggest one, get it out of the road. Thank you very much, Daniel Lizak, if I'm pronouncing that correctly, from Warsaw in Poland. Hi to all my Polish viewers. Do have a fair, sizable contingent. What's in here? Anyway, there are 3 items. Okay. Yes, I right. We have a note. A crusty old phone. Just a touch tone thing. We have schematics of whatever we've got. We always like the schematics. Thank you very much. Oh. Wow, is that a Polish multimeter? Is it? Ah, classic. Look at that. What is it? It's a stereo of some description. Magnetophone. Magnetophone? Is that Polish for speaker? It's a amplifier. Oh, yeah, okay, a stereo tuner. Wow, 2-minute teardown. Awesome. Bloody heavy. Polish analog multimeter. Look at that. Thing of beauty and a joy forever.
Behold the Wonkamobile. Thing of beauty is a joy forever.
20 k ohms per volt. Pretty standard stuff. 50 microamp meter movement. We've got AC, DC, no millivolts for DC. Oh, anyway, oh no, 60 microamps. How does 60 microamps full scale deflection translate to 20 k ohms per volt? I don't get it. It's a little bit crusty, isn't it? Yeah, I feel the quality in that. There we go, for those playing along at home and who can read Polish. A single screw in the center like this was pretty standard fare back in the day. It's just for these sorts of meters. My first meter, the Tandy Radio Shack one. Oh, here we go. Look at that. Straight on the PCB. Oh, no solder mask. Thank you very much. All the tracks are a little bit tarnished, but they are. They do have the solder plate on them. So let's. Whoa, what's that? What's that? That's really strange. It's got copper, like it's just a strap, like a. Wow. Anyway, we do have a little M205 ceramic fuse in there, but geez, isn't it crusty? Look at it's all come off, and the wiring's all crusty. That's pretty terrible, Muriel. And as with all analog meters, there's not much in them. There's just a bunch of range resistors, and that's basically it. Just got a little trimmer on the side, a little carbon trimmer, classic, and that's all she wrote. A couple of resistors in parallel, because you've got to tweak that. So overall, that's one pretty horrible analog meter, but you know, it'd still work. Like, there's nothing in it. There's a resistor, you know, a couple of resistors, some a range switch, and a meter movement. That's all it is. In a touch-tone phone, well, not hugely interested in that, but yeah. But it is made in Poland. Oh, absolute classic. Yeah, that's exactly what you expect a phone of this vintage. There it is. We've got a modicum of input protection there, but it's a phone. Classic single-sided board construction with the look. There we go. Got the hot snot down in there, and the end-on resistor construction like that. Very common back in the day to get the compact size required. And inside the phone, of course, we've got our touch tone controller. No idea what that one is, but 50th week 94. So, you know, mid-90s vintage there. But yeah, that's all it is. A touch tone decoder IC, and then your phone interface. That's it. Like, can you even buy phones like this? I'm sure you can. Sure you can. Check it out. It's a Unitra Amplituner stereo. The Tosca 303 for those playing along at home. Beautiful. Look at that. It's pretty solid as. So let's take a squiz inside and see what we've got. We've got the schematic, but it's a bit hard to read. Let's check it out. Oh, yeah. Wow, we've got some interesting stuff in here. Both single-sided, classic single-sided boards, very common in consumer amplifiers and other stuff like this. We've got all our exposed fuses on the top here. Our mains wiring is held down with a combination of little twisted wire, and there's string in there, and heat shrink. That's a rather interesting cable grommet at the back. Fascinating. And of course, our tuner wire here is this spring, that tuning system. You can see there's our cap over there. There's our tuning cap, and the ultimate goal of this, of course, is to just change the tuning capacitor. So they have they've got the counterweight on here, and that just, you can see the dial moving across there, which then shows up on the main display window. So, but that goes right across. Look at this. It's coming over here like this. It could easily get snagged on that wiring. That's just flapping around in the breeze. They've got, actually, these are just, wow. These look like bulbs. They actually had some light. There's nothing in them now. They've actually came out. Or are they LED? You know, bulb or LED cutouts in there. And that's used as a light guide to light up the tune-in dial on the front. That's pretty how you doing. Look, it's just soldered on there. That's hilarious. Ooh, look. Ever seen a Polish capacitor? Brilliant. But look at all this, like, point-to-point wiring here. There's no, like, it's just, like, what is that? That wire was too short, so they've tacked on a bit of, enamel wire over there. What? That's just, it's terrible. And the power trannies here. Look, TO220, this is kind of interesting. I've never seen this before. They haven't even bothered to bend the leads, are just going down straight like that on, like, looks like they got a mica washer under there, and then this plastic spacer held on with adhesive or glued onto there, which then just separates the leads so that you don't accidentally short them out. But they're all hand soldered, and that's, it's pretty how you doing. I don't think I've ever seen a transparent mains transformer like that. Look at this. You can see the two cores on here, and they're just, you can see the windings right through the wrap. Unbelievable. Well, there's nothing inherently wrong with that. I just find it fascinating. I don't think I've ever seen anything like that before, apart from your toroidal transformers, of course, but not in this sort of C-core configuration. We've got more wiring just sort of, soldered directly onto the board down there, just hacked in. It's pretty terrible. And there's the back for those that want to see it, and well, I have no idea what you'd even call that. That's the speaker connector. I haven't seen that before. It's like a two-way prong thing. If anyone knows, please tell us the name of that thing. Was it purely a Polish standard type thing? Was it used in anything else? I can't recall having seen that anywhere else. And for those who really wanted to see the schematics, there you go. It's a bit rough as guts, but you can still make it out. So thank you very much for sending that in. That is, wow, a Polish tuner from the 1980s or thereabouts vintage. Wow, it did the job, I'm sure. Age probably hasn't been a bit kind to it, but not really do-it-yourself construction, but fairly sort of, crudely kind of handmade, not designed for proper volume production, that's for sure. Fascinating. Hi to all my Melbourne viewers, Melbourne, Australia, that is. Of course, there are other Melbournes around the world, I'm led to believe. But no, it's not Melbourne. It's just Melbourne. No worries. All right, anonymous person who has sent this. No, John. Thank you very much. Ooh. John, some of the boards that made up a Plexus Media Gateway controller originating from Teleca, which was absorbed by Lucent. These were TDM SIP gateways. Wow, there you go. So we've got serial. We're going to have some big hardware on here. Oh yeah, look at that. Wow. Jeez, look at all the passives on the back. Jeez, we'll have a good squiz at that. All right, let me show you all the boards. Jeez, a whole bunch of them. Wow, John, thank you very much. He sent in practically, I would assume, like the full rack of modules for the Plexus Media Gateway, which is basically a VoIP, communications type thing over the internet, which switches into your public telephone network and all that sort of stuff. But we have practically everything that makes up that system: the voice server, the channelized network access, some I/O, we got switch fabric, Ethernet network access, more I/O, DS1E1 interface. We've got the compute module, which runs it all, presumably, quad 10 base T Ethernet, and a channel switching thing, and another one. Oh, wow. I mean, I seriously don't have time to go through all these, so I'll just show you each one briefly. But, wow, we've got some serious network, voice infrastructure hardware here. This is amazing. Now, what you're going to see on all these boards is just an abundance of massive custom hardware designed for this. This is the connector interface, if you want to have a look at that, which goes into the backplane there with the power connectors over there. Well, that's probably, is that more power in the center? I don't know, but just chock full of custom hardware. You could, be an engineer in the industry and spend your whole life just working on whatever that chip is, whatever that one is. I don't know. An NV6 for just go have a look at them. Look at the power modules, as always with these things. Look at this, a Syn Core. I guess they specialize in power bricks, and these things you would desolder these from the board. As I said many times, you don't roll your own solutions for the DC to DC converters on these boards, and they need massive amounts of current for all the low voltage rails for all this hardware. But look at it. It's just absolutely ridiculous. This is the compute module. So whatever it needs to compute, I don't know. Does it do all the packets and stuff? I have no idea. Anyway, look at the denseness of the of the passives on the bottom here. This is just fantastic. Look at this. The PCB layout on this thing, like, your space would have been a serious option. They probably went to a 10 or 12 layer board or something just to fit all this stuff on. This is just ridiculous. And the PCB layout person really didn't like tented vias. I can't see I don't think there's a single... Nothing else is. Everything else seems to have access. I wonder if they had a reason for that. And this one here is the DS1E1J1IO, and once again another massive power brick here. I'll show you this actually. This is a way to get the form factor down on DC to DC converter modules, and I've done this on custom boards. You notice that the ferrites there are embedded in cutouts on the board, and what they've done is they've used loops in the actual copper. I've used, I think I had 12, 14 layers board or something like that on one product that actually had, so we could get all the turns in there, and you clamp the ferrites around through little cutout slots in the PCB, and that's how you can get the thinness of the board, the form factor, right down to as low as possible. Anyway, I've got some Xilinx FPGAs, we've got our Gear chipsets, whatever they're doing. PMC, I'm not even going to try and Google all these and go through it. We've got ourselves a massive daughter board here with, once again, massive BGA parts under there. So that's just a daughter board. And look at the amount of hardware in this thing just to process these E1 packets or whatever it's doing. Unbelievable. Backside for all you backside fanboys. And this board is just for Ethernet network access. There are no Ethernet ports on the front. It's all done through the rack-based system. But this is just what are they creating all these virtual Ethernet interfaces? I have no idea of the topology of this thing. I don't know all the telecommunication system topologies and stuff, but it's just ridiculous. This custom chip down in here is a Tundra. No idea what that is. Fancy looking heatsink down in there. What's under that? Some whiz-bang memory hooked up to that thing? Some speedy thing. And once again, a huge daughter board with all sorts of BGAs on there doing who knows what. Looks like a couple of little Xilinx FPGAs or PLDs in there. I can't actually read that at the moment, but they look like they're something to do with the interface given their proximity to the backplane connectors. Wow, I'm glad I took off the daughter board. We've got some very serious hardware happening down here. There we go, some older school Xilinx XC2V3000. They would have cost a pretty penny for those Vertex back in the day. They might have even been leading edge, were they not? But up here, got a couple of Intel jobbies. What do we got? Some sort of GC IFX thing. I'll have to look at the numbers on those and pull up some data sheets. But yeah, there's some heavy silicon in that. Wow. But if you want heavy silicon, look at the physical size. You thought those things were big and badass. Look at the size of these Gear, if I'm pronouncing that correctly, chipsets. Wow, these things are just massive. How much silicon is inside? What's the size of the die inside this thing? Bloody 25mm die or something? 30mm? Ridiculous. How much did they spend to spin? It's obviously a custom ASIC. To spin that custom ASIC. Like, I wouldn't even want to hazard a guess. And this is the switch fabric board. Once again, there's no connections on the back, the front, sorry, the rack front. It's all it's all through the back plane and everything else. So we can go and have a look. More Xilinx FPGA action here. More big Xilinx Vertex FPGA here, which would have been huge at the time. And more custom Gear, who was spun off from Lucent, I believe it was. And another one of is that the same chipset we saw before? Very kind of similar to what we saw on the other board, but this is a basic switch fabric board, and presumably they used as many of these as they needed for whatever size switch fabric they were looking for. You know, VOIP type switch fabric. They want to route, 10,000 calls at a time. You need X number of cards. And it looks like those little Xilinx and the big Xilinx up here needed some big bulk capacitance decoupling. Look, you can see them surrounding. Actually, they look like 47 mic 16 volt. I'm surprised to find such a high voltage on here. Wow, wonder why they did that. Anyway, they didn't need the same serious decoupling on any of the Agere chipsets. Next up, we have a channelized network access card, whatever the heck that is. More Agere's chipsets, more of these power supply modules. These must have been worth a fortune. Geez, they're all soldered in, unfortunately. You can't just rip them out. You've got to desolder the pins from multi-layer boards to get all those out. But, wow. Just the amount of hardware on these boards is just ridiculous. And this is the voice server. Look at these bad boys, Vertex 2 Pros. I believe these are upwards of $1,000 per FPGA. So surrounded, but well, and they've got another one over there. But look at all those shiny packages. Surrounded by these Centillium. So I have no idea who or what Centillium is. Maybe we can, you won't be able to get a data sheet for this thing, right? And these are, anyway, this is the voice processor board. For this, yeah, it processes the voice. What it actually does to do that, I don't know what that involves. I don't know, it takes analog stuff, but once again, there's no connections on the front. It's all done through the fabric at the back here. It's all digital I/O. It's not like there's any analog coming into this thing. So it's digitally encoding the voice, doing the real-time compression, doing whatever, digitizing maybe the direct audio stream coming from the ADCs or whatnot. I have no idea. Once again, whole bunch of little TI power bricks around here. You would salvage out these are just some off-the-shelf memory stuff. But so the Centillium chipsets obviously do the voice processing. The Vertex 2 Pros in here, they're probably just gluing all that together. Some part of the switch fabric or something like that, but they're beefy FPGAs for doing that sort of thing. So yeah, I really want to find out what those Centilliums do. You're not going to believe it. I actually found a data sheet for this thing, and there's somebody in eBay selling them for $5 a pop. Okay, maybe they're often used replacements. You have to re-chip these things if one goes bad. Maybe it's worth it. And sure enough, it's a VOIP processing chipset, a fully customized ASIC for just this particular task. So yeah, the Vertex 2 Pros probably just maybe join in all those together. I don't know how many channels these things are or whatnot, but yeah, heavy duty silicon. And then we have this Ethernet board. There's nothing but an Ethernet controller on there. So they obviously had these short form factor cards like this. Whether or not they put those onto a dummy like an extender board at the back, I don't know. And then we have a channelized network quad OC3 interface. So there's the fiber port. So these would be the direct OC3 fiber links for this thing. But it's basically nothing. There's the fiber transceiver in there, just basically going straight out to the matrix, to the backplane on the back. Aha, rear card. Aha. So these actually sit on the rear. Like the other ones are designed to sit in the front of the rack. These are designed to plug into the rear and are a shorter form factor, obviously, and have all of the I/O type interface stuff. Interesting. And last but certainly not least, it's the DS1, E1, J1 I/O. So look, they use these Centronics type D connectors. God, so old school, I can't even remember the name. Isn't that embarrassing? But look at all this. Individual relay control for each channel. Wow, nice. There you go. Suck those off if you need some surface mount relays. And then we've got the isolation interface. We've got individually fused on each one. Wow, so, if you blew the arse out of one, you'd have to get in there and resolder the fuse. Looks like we've got some, maybe, would that be a transorb? Or something like that, perhaps, for line protection? My guess, I don't think it's a diode. And sure enough, they are specific little fuse thyristors designed specifically for this application, for line protection transients. This is the bottom of the board, by the way. We have more fuses. We have more little, what? They're weird-ass looking relays, aren't they? What the hell package is that? That is a fascinating almost socketed-like connection. That is weird. I've never seen that lead style before. Anyone? Bueller? Anyway, there's basically no active circuitry on this thing. It's just protection, isolation, switching, stuff like that goes straight into the backplane fabric. So that is fascinating. Thank you very much, John, for sending in all that hardware. Just the amount of engineering that's gone into these things, like, it dwarfs the engineering that goes into a modern PC, for example. Nothing compared to dedicated custom hardware in a otherwise boring, in quote marks, industry like telecommunications, right? You work at one of these large telecommunications companies, you can make a whole career just designing these sorts of chipsets. Absolutely phenomenal amount of engineering goes in. I'd love to do the PCB layout on one of these jobbies. Take months. It's fun. More fun than a barrel of monkeys. Thanks, John. Sorry, already opened this one. That's what happens when you don't put Mailbag on the front. If you're going to send something in, send it to Mailbag, because I get stuff sent to my regular PO box as well. If it doesn't have Mailbag, if it doesn't have the Mailbag vibe, I open it, because I forget stuff I've ordered and things like that. Anyway, let's have a look. Although I haven't actually looked at it yet. Thank you very much, Annie Brox from Origo. I'll link him in down below. This is the Controllino, is it? Mega. So I assume it's some sort of, from Austria. Hi to all my Austrian viewers. Anyway, some sort of industrial-based, DIN rail mount. Thank you very much. Oh, look. It's even got EEVblog branding on it. Sweet. Thank you very much. Isn't that jazzy? I'm not into DIN controllers. Oh, it's even got EEVblog on the end as well. Obviously, they can custom silkscreen these things. Anyway, made in the EU. Not this made in China rubbish. Anyway, it's obviously, I assume, some sort of Arduino-based thing. I could be completely and utterly wrong. But we're going to have a quick 2-minute teardown. Love all the Phoenix contact connectors on there. Fantastic. I love controllers. I love PLC controls. Still a bit of a ladder logic fanboy myself. Just saying. Let's check it out. So this is the Controllino from Origo. There we go. EEVblog branded. Absolutely fantastic little thing. It plugs onto the DIN rail, of course. There you go. The CE marks, all the rest of it. Made in the EU. Woot! Designed for up to 55-degree operation, 12 or 24-volt operation. I'm not sure, why can't you use 15 or something like that? Anyway, I do like the Mimic panel type interface. These are going to be all individual LEDs for each of the outputs here. We've got, PWM stuff. There's our ground and power input. Of course, it needs to be high power because you can drive high power stuff with these things, presumably. So we've got digital outputs with PWMs. What do we got here? Oh, we've got analog inputs, presumably. Oh, we've got a fixed 5-volt output there, do we? And a whole bunch of relays and stuff. Let's crack it open, see what's inside. Got our surface mount LEDs right down in there, and you'll wonder, well, how do we get them right up? Well, look at those light pipes. A whole bunch of light pipes going up to the cutouts on the front panel. That's great. I can't actually get this top board off because it looks to be completely soldered on both sides. Look at that. There you go. Well, I think I might have accidentally hit one of them when I tried to prise it out of the case. Oops, better fix that. Thankfully, the top board does come off, and we've got an ATmega 2560 and all the requisite interfaces to go along with that. So obviously nothing's going to be hooked up directly to the processor, and of course you don't want that in an industrial controller. I don't know what sort of protection, I don't know specifically what devices they've used down there, but they would be input protection on each of the channels. So yeah, they've done their job. And here's the bottom of the top board with the Ethernet. Got ourselves a WIZnet Ethernet interface, little micro, a little Atmel micro as well. That'd be handling the USB interface or the Arduino side of things, basically. because I believe this is an Arduino interface. 74HC14s for interface stuff, and that's about all she wrote. And I can't see what's on the bottom of that board, because as I said, I can't get it off. It's soldered in place. Is that puppy some sort of battery backup or super cap for for a real-time clock? Anyway, big automotive blade fuse in there, so that's nice. So apart from that, they've got the requisite high current traces anyway. It looks to be quite nicely designed and assembled. I like that for a DIN rail industrial controller. It's exactly what you expect. And for those that want to see the relays, I can't say I've seen those one before. HF41F, HF. Anyway, Underwriters Lab listed. Got to be good. And is it open source? They've got a GitHub page for it. Anyway, let's follow the quick start guide, shall we? And have a look. Isn't this quite nice? Right, let's plug it in, see if we can do anything. There you go. Arduino Boards Manager. It should just show up as an Arduino board. Should be that simple in theory. Let's give it a whirl. Now, I'd love to show you this working, but unfortunately, it's not. Look, I'm getting these error messages down here, so I don't have time to troubleshoot this. Unfortunately, I need to get on with it, and but it installed no problems whatsoever. The drive, I installed a new Arduino environment. It connected to the board, the JSON file, the board manager. It's all there. So if you actually go in and have a look here, you can see that it is actually on there. The Controllino Mega is selected down there. We've got COM3, get board information. It's all, it's all happy as Larry, but then, and it compiles, but then when I try and download the thing, it just does not download. So I've got no idea what's going on there. Anyway, this, look, you can see my fat little fingers are causing those LEDs to update. So obviously the high impedance input, I'm obviously connecting, exceeding the logic threshold there, and it's treating those as input data. But anyway, unfortunately, I don't know. I don't have time to look at it. Anyway, bummer. I'll link it in down below, but it's supposed to be that easy. I'm probably doing something dumb in Arduino, so it could certainly be a PEBCAC, but I followed all the installation instructions. I'm running the example, which you get with it, by the way, which is examples down here, the Controllino, there it is, the Mega, and I'm doing the port manipulation one, but it doesn't seem to be working, so bugged if I know. Anyway, it's a neat little controller linked in down below if you want to check it out. Definitely, if you are used to the Arduino environment, you want an industrial controller, it could be the duck's guts for you. Thank you very much, Luke Valenti from Tiny FPGA. Guess what's going to be inside from El Dorado Hills in California. Hi to all my viewers in El Dorado. Sounds like there's gold in them there hills. Here we go. Let's have a look. Yeah, like spoiler alert, his company's called Tiny FPGA. Extensive letter. All sorts of prototypes. Boards. We do like, oh wow, okay. Lots of little FPGA, presumably FPGA to dip breakouts, which is very handy because you can get really ridiculously cheap and powerful FPGAs these days, but you almost always exclusively come in pain in the ass little QFN packages, and to get them to put them to a dip thing is fantastic. And you can pause this video at any time to read Luke's letter, but send in a basic bunch of FPGA boards based on the Lattice Mark X02 FPGAs, cute little beasties they are, and he's also going to show us, warts and all, the soldering hall of shame, some early failures that he did. Anyway, if you are interested in trying out the boards, check out the website, tinyfpga, nice and easy to remember, .com. Thank you very much, Luke. Let's have a look at them. So I've obviously got some little Lattice Mark XO FPGAs on there, tiny little bastards, and very easy to plug into your breadboard because they're just on the dip sockets. Also a little tiny FPGA programmer as well. That's just a little JTAG interface, and soldering hall of shame. Let's have a look. Wah, 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 wah. Anyway, thank you very much, Luke, for being not ashamed to show us your soldering fails back trying to do these 32-pin pain in the ass QFN packages. I think I've done a video on soldering QFN. He started with just an iron and a generic breakout board, and it ended miserably, as you can see here, but he finally got a proper solder paste stencil, which you don't necessarily need. I've done a video on that without it. An electric griddle? We don't call them griddles in Australia. An electric grill, I guess he's talking about. And a low temperature lead-free solder paste did the trick. And the subsequent ones are done on a Controllino 2 kit oven for those playing along at home. So yeah, that one's almost there, is it? Hasn't cleaned up the flux residue, but get in there. Oh, yeah, that one didn't end nicely, did it? Oops. So it's improved over time to where it's nigh on perfect, is it? Beautiful. And there's the V-scored panel for those playing along at home who like their panels. Yeah, very easy. You would do something like this with V-score. You wouldn't bother wasting space on there with any routing. I've done a DFM video on that, haven't I? Which is incredibly popular. I think it's one of my most popular videos. Anyway, thank you very much, Luke. I'll link in Tiny FPGA down below if you want to get into the Mark XO programmers. Oh, Mark X0 FPGAs and program them. Yeah, that's what I meant to say. Thanks, Luke. Thank you very much, Ryan DaCosta. He's from India. Bengaluru? In India. Geez, hi to all my Indian viewers. We don't get many from India. I don't think I have a big contingent. I get quite a lot of email from India, though, but yeah, it doesn't. India doesn't show up on like the YouTube stats and stuff like that. Not anywhere near the top. I'm not going to say the top 20, but yes, they do punch above their weight in terms of email. Or we have a Bolt. That's the Bolt IO ESP something or other Internet of Things something or other board. Let's take a look at it. We have a 5-minute challenge from Ryan from Bolt IO, who reckons this Internet of Things widget I can be up and running in 5 minutes. Create an account on cloud.boltio.com and Bob's your uncle, apparently. Let's give it a go. I have a stopwatch. Almost 3 minutes into it and I just figured out that I have to hook up my bloody phone. I just wanted to use my PC to control bloody phone. Urgh. It seems to not want to work unless I give it access to my location. Piss off. Please turn off my mobile data. Why? 6 minutes 40 in, and apparently I'm connected to my Bolt IO device after giving it my bloody access to my location. I took one for the team, but screw you, and turning off my mobile data. Unbelievable. Alright, please explain why it shows up as offline. Why isn't it online? Sitting there flashing its blue silly LED, which it says trying to connect, like, what? So we're going to follow the guide and go in and create a project. Dumbo. With, let's see if we can flash a LED. I have to choose a bloody icon file? Why? So I chose a random bloody image. I'm clicking on done and nothing's happening. Oh, just want to flash a LED. 17 minutes in and I'm getting there. Looks like I can GPIO 0, digital, variable name, I don't know, LED. Okay, so that's the hardware. That's the code. I can start typing my code. Woohoo! And now I've got to go down here. Here we go. I can enter my code, led.html, at a GitHub link. You mean to tell me I've got to go to a bloody GitHub and download it, and this is all your code for a LED? Gotta be shitting me. Alright, so I go to this stupid link that you provided in the Getting Started guide to your silly GitHub page. Freaking GitHub. I shouldn't have to dick around with GitHub just to flash a bloody LED on an out-of-the-box Internet of Things demo. This is bloody ridiculous. Anyway, LED control, we can go, like, there's a test bulb HTML thing. Oh, now we're in. So I've got to manually copy and paste all this, do I? How the hell do I do that? I don't know. I don't use freaking GitHub. Ah, unbelievable. So I go over there, then I start typing your code here. Paste. Wow. I need to do all that. Document.getElement? What? GetElement? What GetElement by ID? My image source? Clicker? What? Clocker? What is all this shit to flash a LED? This is a joke, right? Next I've got to do some stupid thing about linking the product. Well, okay. And then I've got to generate API keys to enable the API allows you to securely access the bolt for controlling pins. Bugger off. So I've got to go into here, apparently. API. What do I have to do? Enable my bloody API. API credentials disable. I've got to enable. Do I? Enable the API which allows you to securely access blah, blah, freaking blah. And then what? What do I do with the API key? I know what I'd like to do with the bloody API key. Right, so now it tells me to go back to the home page. I generated my API key. I've copied it. It tells me to click on this actions thing. Page nut, without an O, not found. What the? I'm following your stupid instruction guide, and I'm supposed to get some stupid big push button thing, which is supposed to let me flash the LED, but it doesn't bloody work. Is that because it's offline? Well, it shows that it's offline in here. Look at this. Like, what? It just doesn't work. I don't care. I'm done. It's 27 minutes of my life I want back for this stupid thing. Internet of bloody things. Go follow the Internet of Shit account on Twitter. It's very apt. Thanks for sending that in, Ryan, but sorry, that is a complete and epic fail. I'm not going to spend the time to bloody troubleshoot the thing. It just, no. We have a random electronic module. It comes from Singapore. Yeah, maybe somebody ordered something on eBay. I do get a lot of eBay stuff. I haven't opened them. I actually, I'm going to have to try and find it. I actually was going to do a Chinese mailbag special, like a whole bunch of stuff, just random eBay items that people have sent me in. And I did actually shoot a lot of footage from that. And it's somewhere. The footage is somewhere. Trust me. I'll see if I can find it. Ooh. I am a fanboy of the old school ZIF socket. Look at that. The old school 3M ZIF socket. Fantastic. Yep. Genuine 3M text tool. Yep. So I've got an LCD. And it's some sort of programmer. What programmer is it? It just says electronic module. There's nothing. What do I have to, well, I got to put a 9-volt battery in and power up. It'll probably tell me. Let's give it a go. So what on earth is this thing? We've got presumably a programming button, an LCD, which should show us some info, and a little, 14-pin ZIF socket. There we go. Just got a micro on the back, not much else. Maybe a couple of trannies up there to do some switching, but, well, let's plug in our 9-volt battery and try it, shall we? Oh, hello? Oh, replace the battery. Oops, sorry. This is quite possibly the worst LCD display in history. Hang on, here we go. Watch this. M tester. What sort of M? No, unknown or damaged part. What the hell's an M tester? Memory? Like, does it test the least squared problems or something? What? Well, I found this on eBay. It's like $6 or $7 delivered or something, and it's apparently a diode transistor tester / LCR meter all in one. That's just... it's horrid. Like, nothing. The LCD doesn't work properly. Can't even read it. The bloody... nothing's labelled. Hasn't got proper sockets for transistor LCR testing. I just don't understand why these things exist. I'm done. Catch you next time.